Alright, so this is what we started yesterday before our little interruption. And
More than a little.
it was just a little interruption. Alright, so let's take a look. What we're going to talk about. What was our topic yesterday? I didn't write it down here, but what we were trying to find. Yeah, we're trying to find the midpoint of this thing. So let's write that down. I didn't write that down. And so what did I do? I just picked a couple random points on here, connected them, right? So I've got a line segment, and I'm trying to figure out how to find the midpoint between them. If you remember, we erased it, but we said, remember, you're on the road, and you're at mile markers. I forget what numbers we used. What did we use? Like 2 and 10? Is that what we used? Okay. So if we said we were at 2 and 10 and you wanted to get to the halfway point, you're going to meet somebody there. What mile marker, not how far is it, but what mile marker are you at? What is the midpoint? Okay, it's 6. So how'd you do that? You could do it a couple ways, but what's the easiest way that we came up with? Nah, that was probably not the easiest way. There was an easier way. Yeah, I would add them up. Now, it doesn't matter which order you add them up. Can I go 10 plus 2 or 2 plus 10? Does that make any difference? No, not at all. Okay, but then what do you have to do? 10 plus 2, that's 12. There's no way that's 12, right? So what do? Right, you divide it by 2. So that's 12 divided by 2 is 6, and so 6 mile marker would be the midpoint. Follow me? So how do you find the midpoint of a line? You add the two endpoints, and you divide by 2. Everybody got that? Okay, we'll erase this again. So you just have to remember that. Now what we're going to do is this. But this is a diagonal line. You can't just say, okay, I'm just going to add this point to this point and divide by 2. But you kind of do, though.
Add the x's and not the y.
That's right. You do the x's, right? You take the x coordinates, right? You add those up and you divide by 2. And then you take the y coordinates. You add them up and you divide by 2. Does that make sense? All right. And that's what I was starting to do right here with these yellow lines. So let's see. I don't know if that's close enough. It's not perfectly vertical, but you get the idea. Okay, so really what we're going to do is we're really finding the midpoint of this line, and we're finding the midpoint of this line. So if I go midpoint here, it's going to go up to there. If I go to the midpoint of this one, it's going to go over to here. So your midpoint's going to be about right there, isn't it? All right. But what did we just talk about? We said, how do you find the midpoint? Just add the endpoints together, divide by 2. So let's not even worry about the yellow lines, to tell you the truth. Now, when I usually teach midpoint, I usually talk about that, but I think we're okay. So what do? We add the x's together, so 3 plus negative 6, or 3 minus 6, and divide by 2. Does it matter what order we add the x's in? Doesn't matter at all, okay? As long as you make that 6 a negative 6 and make sure that 3 is a positive 3, add them together, and you've got your x part of the midpoint, right? So the midpoint's probably going to be right in there somewhere, isn't it? All right, so let's do the y. So that's how you find the x. How do you find the y? Well, you take the y's and you just add them up and divide by 2. So again, it doesn't matter what order you add them up. I'm just going to go 5 plus what? What am I adding to 5? Not 2, negative 2. All right, it's a big, that really is important that you make sure you carry along the sign. All right, divide by 2. And so let's do this. 3 plus negative 6, what's that? Negative 3, isn't it? Negative 3 over 2. And what is negative 3 over 2? Because we have to plot it on our graph. It's negative 1.5, isn't it? Okay. Now, I just randomly picked these numbers. I probably could have picked better numbers to come out. But anyway. Well, I mean, to figure out where this is, I mean, 3 halves doesn't make much sense to you. But what makes more sense? Because there's 1 and there's 2, right? So it's what? It's negative 1.5, right? So you know, you could write it. I mean, when I ask you what the actual midpoint is, you could use that, all right? But if you actually wanted to plot it and put it on the graph, you'd probably want to turn it into this. But if all I did is just say find the midpoint, you could keep it negative 3 over 2. It's perfectly fine, all right? If you want to make it negative 1.5, you can do that too. I have no issue with either one of those. So what's this y part going to be? 5 plus negative 2 is what? 3. Positive 2. So look at this. You went negative 1.5 and you did what? You went up 1.5, didn't you? So that's a 1 here. That's probably like a 2 around in here, and that's halfway. Do you see that? So we went negative 1.5 and we went up 1.5, and that puts us right there, and that's our midpoint. Now again, like we just said, you could write it negative 3 halves, positive 3 halves. If you wanted to write it negative 1.5 and positive 1.5, that's fine as well. I don't see why you would want to, because you've already got it right there, don't you? Okay, why even bother changing it to this? if all they ask for is the midpoint. But if you wanted to plot it and you wanted to put it on the line itself, yeah, it makes a little more sense saying -1.5, +1.5. We good with that? Pretty easy. Let me just write down what the formula is. So in order to do the midpoint, it's an actual point, isn't it? It's an ordered pair. I'm not finding out how long the line is, am I? Okay, I'm finding not a distance, but an actual point. And this is where a lot of people get confused. I see people doing midpoint and giving me just like one number. Well, that tells me something. That tells me you have no understanding of what you're trying to find when you're finding the midpoint. What do you try to find when you find a midpoint? You're trying to find an actual point, right? How do you write a point? You write a point as an ordered pair. Okay, so midpoint has to be an ordered pair. Don't just write a number. Okay, don't just write one number for a midpoint, because again, that tells me that you have no idea what you're doing. All right, if you just write just a number, because the midpoint is a point. It's an ordered pair. You got to have two parts to it. So what did we do? We added up the x's, didn't we? So how should I show that with an equation? We'll call it x what? 1 plus, what do you think? X 2, just kind of like we did with the distance, right? You got two x's here, don't you? You've got one here, and you've got one right there. So what did I do to those two right here? I added them up. That was my x1, that's my x2, so I add those up. Then what did I do with it after I added them up? Divided by 2, didn't I? So I'm going to put this and divide it by 2. Does that formula make sense? Sure, because it just says you take the two x's, you add them up, and you divide by 2. Then what else did you do? Yeah, you added up the y's, didn't you? So you'd take the y1 plus y2, and you divided by 2 there. So this just means you add up the x's and you divide by 2. And that's how you find the midpoint. Just like that mile marker thing. Remember that when you're doing midpoint. Okay, what did he say? You started off at the 2-mile marker, ended off at 10. How did you find the midpoint? You added them up, and you divided by 2. That's the easiest way to do this. And that's your midpoint formula right there. Now that's different than the distance formula. And you're finding something completely different, right? If I said find the distance, because some of the problems on here ask you to do two things, right? The first two problems on that worksheet I gave you, it'll say find the distance and find the midpoint. So you got to know the difference between the two things. All right, so they give you the 2 points and you have to find the distance between them. That's one thing you have to find. Okay, I'll put distance, right? And then you have to find this point right here, which is what? The midpoint. They're two completely different formulas. That's the formula for midpoint. Do you remember what the distance formula is? Big old square root, right? And then it looks like what? Where did we get it from? We got it from the Pythagorean Theorem. Exactly right. So this kind of looks like Pythagorean Theorem, doesn't it? A squared plus b squared equals c squared. It's just that we got the c, or in this case the d for distance. We just got rid of the squared and made a big old square root. Alright, so how do we find the distance between 2 points? We just subtract them from each other, right? That's how you find out how long it is from one endpoint to the other. And then what'd you do to the y's? Do the same thing with the y's. So if you realize this is basically the Pythagorean Theorem, you're good to go. I've seen some books do this, and that's perfectly fine as well. Because sometimes that big square root's a little intimidating to students, okay? And they look at that thing and are like, oh no, I'll never be able to do it. But it's just a square root. It's not that big of a deal. But really, look at this. Isn't this basically the same as Pythagorean Theorem? This is kind of like the c squared, the hypotenuse, right? And what is this? This is one of the legs, right, of my right triangle. So that's like my a squared. This is the other leg of the triangle, and that's like my b squared. So isn't this basically taken from Pythagorean Theorem? Yeah, absolutely. So if you can remember Pythagorean Theorem, you should be able to remember the distance formula. But why don't I normally write it like that? Well, I don't know, just because they wanted the d completely by itself. You could remember it like that, right? Might look a little cleaner for you. It's up to you. But they do this. They get rid of the squared here. So if I get rid of this squared, what do I have to do? Take the square root. And so that's why they put the big old square root there. Okay? Again, sometimes that square root's a little intimidating, and some people get scared off by that thing. But that's why they do it. So there's your two formulas. And you have to memorize them. I'm not going to write them on the test or anything. They're formulas that you need to know. Everybody got it? And I think we went through enough explanation on how we got to them. Okay, I didn't just sit here and say, okay, here's the formula, memorize it, here's how to use it, boom, we're done. And you probably wish I would do that every once in a while. But I think it's important to understand where they come from. Okay, understand why this formula is written the way it is, and why this formula is written the way it is. Yeah. It kind of is, right. The distance formula is kind of the same as the equation of a circle, because if you remember when we did this, how did we get the equation of a circle? Basically, it's just the distance or the length of the radius. Okay, that's basically what it was. Let me grab a circle right here. I'll put that right in the middle. Okay, so do you remember how we came up with the equation of a circle? We basically just found the distance or the length of that radius. That's what the distance formula is of a circle, right? This is the origin or the center of the circle. You remember what letters we used for the center of the circle? The H and K, good. And then this right here, we don't know that point, and we used X and Y. So really, how do I find the distance of that radius right there? We'll call it R for radius. So what do? Right? We just do this, right? It's basically just the distance formula. So what would the distance formula of this little line be? Well, instead of D, it's what? It's R. Okay? And we could put squared, or you could put R equals big old square root, couldn't you? All right? And then equals what? It's basically just Pythagorean Theorem. Would you agree? So how do we do this? We went X minus what? H. So instead of X1 minus X2, instead of calling this X2, we called it H, right? Because it's specific. It's a specific point. It's the center of the circle. So it's X minus H, and what's this one? Y minus K. So this really is the distance formula, isn't it? So it's a good observation, because the distance formula is really the same as the equation of a circle, except the equation of a circle, this is a little more specific, okay? It's not just any old distance, it's actually the radius of that particular circle, okay? If you wanted to, you could, what's this, why is it doing that? I just hit Control Z. Okay, there we go. If you wanted to, you could get rid of that squared, couldn't you? And write it like this. Now, I don't know why people don't normally write the equation of a circle like this. They usually put R squared here instead of the square root. But you could, right? It'd be the same exact thing. But it just looks a little cleaner, looks a little nicer if you just do it like that. And again, there are some books, instead of writing a big old square root here, they put D squared equals all this without the square root. It's just up to the author of the book how they think it's best to write it. Okay? We good? All right. Let's continue with a little bit different. We're still going to use Pythagorean Theorem. We're going to still look at a few things. Let me see the problem. Okay, here's what we're going to do. I think I found a good example. I'm going to give you 3 points. Now, 3 points, if I plot 3 points, I could probably form a what? What kind of a figure? What kind of polygon? A triangle, right? Okay, so let's put the 3 points here. Let's take a look and look at that triangle. And the question is, if you look on your worksheet, you'll see a set of questions, maybe about, how many do you have, like 2 of them, where it says determine if it's a right triangle or not. Did I give 2 of them? Okay. So here's one. This is what you're going to do. And it's all about distance equation, the distance formula. So make sure you know how to do the distance formula, because we're actually going to do it twice here. Get rid of that. So here's the question. The question says determine whether these 3 points form a right triangle. And basically you say yes it does or no it doesn't. All right, now you could just guess. All right, you got a 50-50 shot, right? But do you really want to go into a test with just a 50% chance of getting it right? No. I like better odds than just 50%. All right, so I want to figure out how do I do this. Now you could graph it if you wanted to. Yep.
Looking at the worksheet, if 2 of the x's are the same number, would that make it?
Not necessarily, because you could have a non-right triangle with 2 of the x's the same, and you could have a right triangle with 2 of the x's the same. So it all depends on the other one.
If it has 2 x's and 2 y's.
Well, it's not quite as easy as that. Okay, we don't want to just, like for some specific triangles, you might be able to say, oh yeah, that works here, but it's not going to work for everything. So you can't just died. There it goes. Ah, there we go. Goodness, that was weird. Well, it's not the first time something weird happened this week, right? So, all right, we're good to go now. So let's do this. Let's see what we have. You don't have to graph this thing. All right, that's the kind of nice thing about this. But it does form a triangle. So what are my sides of the triangle? Well, you have MN, don't you? What would another side of my triangle be with these 3 points? MQ. And what's my third side? NQ, right? So we've taken care of all 3 sides, right? So what do we want to do? What we want to do is we want to find the length of all 3 sides. Now, how do I know if it's going to be a right triangle or not? Let's just go backwards a little bit. So how do I know if it's going to be a right triangle? We've discussed that word a couple times already today. So if it makes... Now, we're not really going to know by finding the distance if it makes necessarily a right angle or not. But we can tell if this is a right triangle if what is true? If a squared plus b squared equals c squared. Everybody see that? So if I can take this, that length right there, and it's going to be one of these, isn't it? And I square it, and then I take the other length and I square that, and if it equals the hypotenuse squared, how do I know which one of these is the hypotenuse? It's the longer one, right? The hypotenuse is always the longest side. Okay? So what I'm going to do is I'm going to find the distance. I'm going to do distance formula 3 times here. I'm going to do it for this one, and this one. Then I'm going to figure out which one is the hypotenuse. Okay? How do I know which one the hypotenuse is? It's the longest one. So whatever the longest of these 3 sides is, that's going to be the hypotenuse. Everybody with me so far? And then I'm going to do this. I'm going to take the 2 smaller ones, I'm going to square them, I'm going to add them up, and I'm going to see if it's equal to the hypotenuse squared. If all that stuff is true, if this stuff right here is true, then it's a right triangle. If it's not true, then guess what? It's not a right triangle. Right? Anybody hear anything I just said? I see a lot of blank stares, so that scares me a little bit. But Morgan, you're listening, so good. So let's do this. Let's find the distance of MN. Let's just do it real quick. So distance equals big old square root, and then we do this. We square it. I call this the shell of the formula right here. Okay, and we're just going to plug stuff in. So how do we know what to plug in? We can do the math in our head, I think, on this one. Just show you how quick it is. We subtract the x's and we subtract the y's, right? So let's do MN. It's these 2 right here. Subtract the x's. It doesn't matter what order we subtract them. Let's go 12 minus negative 2. What's 12 minus a negative 2? 12 plus 2, which is 14. Good. Let's do the other one. Again, we're subtracting, right? And it doesn't matter what order we subtract them in. So 5 minus 3, what's 5 minus 3? That's 2 squared 2. I'm sorry. I just want to go 5 minus 3. I don't want to square it just yet, do I? So 5 minus 3 is 2. So let's see what we get. 14 squared. For some reason my, oops, what's going on? Let's get rid of all this. I think, save changes, no. Alright. What's 14 squared? Is 196? Yeah, I knew I'd recognize it. I just couldn't think of it off the top of my head. 196 plus what? 4. It's under a square root, so what do we get? The square root of 200. I don't need to simplify it. I'm just going to keep it like that. Everybody with me so far? That wasn't that big of a deal. Let's do the distance between M and Q. It's the 2 ones on the end. So let's do the same thing. Square root, put the parentheses squared, another parentheses squared, plus in between. So we subtract the x's for M and Q. 10 minus negative 2 is 12, isn't it? It's positive 12. And then let's do the y's. Let's go 5 minus negative 11 is 5 plus 11, which is 16. So what do we get here? We get 144. What's 16 squared? Isn't that like 256 or something like that? Or I forget what it is. Somebody do that for me. 16.
15 is 225.
What is 256? I was right. 250. Add those up for me, Isaiah. 144 plus 256. What is it? 400 even? Okay, good. All right, let's do NQ. It's these 2 right here. See, distance formula isn't hard if you know what to subtract and what to add and all that kind of stuff. All right, let's do NQ. These 2 right here. Let's just subtract the x's. 12 minus 10. Well, 12 minus 10 is 2. Let's do the y's. 3 minus negative 11, which is the same as 3 plus 11, which is 14. And look, that looks familiar, doesn't it? That's a 4, and 14 squared, we already did that, 196, and that's the square root of 200. Now, I have to decide, is this thing a right triangle or not? And how do I do that? Well, I have to go a squared plus b squared equals c squared. If this is true, then it's a right triangle. But how do I know which one is the a, the b, and the c? Well, remember what we said? The hypotenuse is always the longest side. So this is the hypotenuse. That's the c, isn't it? So what are the other two? The a and the b, right? Now watch, you look at it and you're like, oh, square root, I'm going to put that into a calculator and get some decimal answer. No, 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 don't. It's a lot easier because you're squaring a square root. We learned that just recently. It just gets rid of the square root, doesn't it? So let's do that. Let's take the a squared, which is the square, I'm going to write it all out. It's the square root of 200 squared plus b, that's the same thing, isn't it? Square root of 200 squared, and that should equal, if it's a right triangle, it should equal c squared. Let's see if it is. What's the c? Square root of 400, and we have to square it. Now, what did we say? We said the square and the square roots cancel each other out, so that's 200. You probably see it already now, don't you? Those cancel out, and that's a 200. Right? These cancel out, and that's a 400. Are they equal to each other? They absolutely are. 400 equals 400. So, a squared plus b squared does equal c squared in this situation. So, is this a right triangle? Yes, it's a right triangle. All that just to say yes. You're probably thinking I could have just guessed yes, all right? But it would have been a guess. Now, you could graph it, but you got to be careful with that because sometimes it's really, really close, and if your graph isn't real precise, it may look like it's a right triangle, but in reality, it's off just a little bit because you didn't graph it real, careful, and you might be off. So you have to be careful. This way is foolproof, okay? This way will always work. You'll always be able to tell if it's a right triangle or not. Now, what if these two right here did not add up to c squared? Then it wouldn't be a right triangle. Then you would say no. Does that make sense? So that's not that big of a deal. It looks like a lot of writing. A lot of this stuff, though, you could probably do in your head. You could probably just do it in a calculator, to tell you the truth. You could probably... I showed all the steps because I wanted you to see where we're getting all this stuff, but you could have chucked a lot of this in your calculator and just got the numbers there, right? Just figure out what that is and just write square root of 200. Figure out what this is in a calculator, get this, and then it's pretty easy to figure out if they're equal to each other or not, all right? So it really can be a lot quicker than what I did right here. I do a lot of the steps just because I'm teaching it, right? And I got to show you what every single step is. But as far as you actually doing the problem, you could do it a lot quicker than what we have. Well, there are some steps you need to show. I mean, you really should show that you got this, right? I mean, you could do all this in a calculator, but at least write that down. At least write that down, okay? And then show this part right here. So I think this is important right here to show that they do equal each other, and then you can just say yes. All right. Now on a test or quiz, I don't mark the problems right or wrong. I should say I don't mark them wrong if you don't show your work. Right. Now on a homework's a little different, okay? Because I'm not checking the problems if they're right or wrong. You don't get graded if they're right or wrong. You just graded if you gave some effort. And I do want to see a little bit of effort on this. All right. But you don't have to show every single step that I did. For some of you though, you may need to. Because some of you guys start chucking stuff into a calculator and you get lost pretty quick. And it's good to at least have this stuff written down so you can always go back and check it. Alright? Let's do one more like this and quit, okay? It's not exactly like this, but watch this. What's the other thing? It says determine if the points are collinear. Well, what does that mean? What does collinear mean? We talked about this in my geometry class. I don't know if we talked about it in here. Yeah, it lines up in a line. That's right, collinear. So if I took a point here, and a point here, and I call this A, B, and C, are those 3 points? Are the 3 points collinear? No, they're not, because they don't all lie on the same line. A, B, and C don't all line up, do they?
I just found the slope of each.
Okay, watch this. What if we did this? Well, it's not necessarily the slope of each one. It's really the distance. I'm going to show you here in a second. Watch this. What if I call this X, Y, and Z? Is X, Y, and Z, are they collinear? Yeah, they are. Okay, they are collinear. Why? Because they lie on the same line. Would you agree? How in the world can you tell? What if I gave you the points as ordered pairs? Okay, how do you know if it's going to be, because it doesn't have to be horizontal, does it? I mean, you could have a line that's like this, couldn't you? All right. So, and you could still have points collinear on this. Would you agree? All right. So it's not necessarily horizontal like this one. Okay, it could be slanted, it could be diagonal. All right, and you have to determine, are those points collinear? Well, let me just show you a quick little example. If I take xy and found the distance, we'll call it distance 1, and if I took yz and I added those up, what do you think they're going to add up to be? If I take the shortest one and the longer one, what do you think it, not a number, but in reference to this whole line right there. So this little distance and this little distance add up to what? The whole thing. Would you agree? We'll call it D3 if you wanted to. I don't care. Okay. Do you see that? So how do you determine if they're collinear? If I take one distance and I add it to the other distance, right? Take the two smaller distances, it needs to add up to be the third distance. It's a little different than the right triangle. What's different about this compared to the right triangle? What did we do with the right triangle? We took the two smaller distances, right? And then we did what to them? We didn't just add them together, we did something to them first. What did we do? We squared them, didn't we? You see that? So in order to determine if it's a right triangle, we took the two smaller distances, we squared them, then we added them up, and then we saw if it was equal to the longest distance squared. This is actually a little bit easier. What do? You take the d1, the smaller distance, plus the middle distance, okay, if you want to call it that. If they add up to be exactly d3, then it's going to be collinear. Make sense? Because watch, if this d2 was slanted up, would they add up to be that whole straight line right there? No, they wouldn't. All right? I could give you more explanation, but let's just realize that. So D1, we'll call it D1 plus D2. Those are the two smaller distances. Okay? It needs to equal the largest distance. Okay? The longest of the three. So again, what are we going to do? We're going to give you 3 points. And you're going to find the distance again between those 3 points. Take the two smaller ones, and if it adds up to be the largest one, then it's collinear. If they don't add up to be the largest one, then they're not collinear. And that's what they're going to ask you to do. So let's do an example from the book. So here's 1 point, negative 1, 5. They actually don't label these with letters, but I'm going to. This is 2, negative 4. And then the third one is 4, negative 10. Let's make that C. 4, negative 10. All right, so what is the question now? The question is not whether they make a right triangle, but whether they are collinear. So what do we need to do? We need to add up the 3, or not add up, but we need to find the 3 distances. So let's list them again. AB, BC, and AC. All right, those are our distances. So let's find the distance. All right, we'll do all the work. Okay, so AB. We could just do this like this and this. Let's just do the math in our head. All right. So 2 minus negative 1, that's 3 squared. And this is 5 minus negative 4, and that's 9 squared. What is that? That's 9 plus 81, and that's what? Square root of 90. Okay. And there might be a time where we want to put that into a calculator. We'll see how it works out. Let's do BC. See, doing the distance doesn't take that long, does it? It's really not that big of a deal. Okay, as long as you know what you're doing, it's not that hard. So BC, these two right here. So subtract the x's. 4 minus 2 is 2. And then negative 10 minus negative 4. If you can't do that in your head, write it out. Negative 10 minus negative 4. That goes to plus, what's that? Negative 6. But negative 6 squared, well, actually, just put a 6 in there. Remember, it doesn't matter if it's positive or negative. When you square the negative, it comes out positive. So what do we get? We get 4 plus 36, and that's the square root of 40. All right, let's do AC. AC, square root, parentheses and squareds, add them up. All right, here we go. AC, subtract the x's. 4 minus negative 1, that's 5. Let's do the y's. 5 minus negative 10, that's 15. And that is 25 plus, what's 15 squared? 225, is that right? Somebody do that real quick, just so I don't mess up. Okay. All right, good. 25 plus 225 square root, and what's that? That's 250, right? Now, what are we trying to do now? Now we got the distances of all three. It's the same exact thing that we did when we determined if it was a right triangle or not. But now we don't square them both. What do? We take the two smaller ones and we do what? Add them up and see if it equals what? 250. Square root of 250. We can't just get rid of the square roots this time, okay? So this is where you might want to use a calculator. So what are the two smaller ones? Well, the square root of 90 plus the square root of 40, right? Now, I'm going to put an equal sign, but I'm going to put a question mark above it. I should have done that before because I'm not really sure if they equal or not, okay? Now, that should equal the square root of 250. So somebody do that on a calculator. Actually, for some reason, my calculator bugged out on me. So let me just let me get my calculator up and ready. Okay, and so what are we doing? We're doing the square root of 90, right? So the square root of 90, we can do the whole thing, can't we? Plus the square root of, what was it, 40? And let's see what that's sorry. There we go. And that equals 15.8. So let's put that on there. So this comes out to 15.8. Now, if it's collinear, that square root of 250 should come out to the same exact thing, shouldn't it? So the square root of 250, same exact number, isn't it? So look at these. This example, so that's also 15.8. So, are these 3 points collinear? Yes, they are. Now again, you could have graphed them if you wanted to. Right? You could have graphed them and looked at them and see if they line up on a nice perfect straight line. But one of those points might have been just slightly off and you might not have been able to tell that, right, by graphing it because your graph might have been a little bit sloppy. So this is going to work every single time. That's the nice thing about doing it this way instead of graphing it. Now, if you want to graph it, take your chances that you graphed it perfectly, then that's fine, all right, if you want to do that. But I'm just showing you how to do this perfect every single time. This will always work. So these 3 points right here, if I graphed them, they would all three line up on the same line. Okay, you couldn't make a right triangle out of it. You couldn't make a triangle at all out of it. They'd all line up on one straight line, and then that's all they're telling you to do. So what do you say? You say yes. Yes, what? It's collinear, right? Collinear means it lies on a straight line. They all three make up a straight line. Got it? So just quick review. How did we figure out if it made a right triangle? We found the three distances, and then we had to go a squared plus b squared equals c squared, right? We took the two smaller ones, squared them, added up, and they had to equal the largest side squared. If they do equal, then yes, it's a right triangle. I should say this. Yes, it's a right triangle. All right? Now, how do we know if they're collinear? Well, you start off the same way. You find the distance of all three segments. Then what do? You don't square them. You just add them up, straight up. All right? Just add them up. I put them in a calculator. Do they add up to equal the longest side? Absolutely they do. So yes, it's what? Collinear. And there you go. Still have one more thing. Now you should be able to do now on this homework, you should be able to do 3, 4, 5, 6. And we still have to do 9 and 10, right? And we'll cover that tomorrow. So tomorrow we'll do 9 and 10. And we'll take the whole period to do that because that gets a little bit more complicated. Do you remember completing, wait a minute, let me finish. Do you remember completing the square? Remember doing that stuff, completing the square? We're going to have to revisit that, okay? I told you not to forget anything that we've learned before. So we're going to go back to completing the, we're going to go back to completing the square, and we're going to do a little bit of that with circles. So just wait for tomorrow. So you should be able to do everything except for 9 and 10 on that worksheet. So have that done for tomorrow. Tiffany, you got a point?
I was going to say, I figured out 9, like, I'm having a little bit of difficulty with
on 10. Yeah, 9 and 10 are a little bit more involved. That's why I wanted to just take one class period just to focus on that and not to look at anything else. Okay, so we'll do that tomorrow.